Welcome back, folks, to Module 3, Lesson 2, where we're going to be working on subtracting integers. Now, once again, we've already been tinkering with this year, but now we're really going to hammer it out because it's something that you need to be rock solid on. Now, the textbook does a pretty good job of showing you how to subtract integers with a number line, and while that is an important skill to understand, it's not the goal of what we're doing today, because on my tests and on the quizzes, I'm going to expect you to be able to just do it using big kid math. But let's look at it at a number line now and see how it's going to work. They give you the problem 4 minus 9 is equal to negative 5. And you see, you always start with counting from 0. So they went from 0 and they added 4 to it to deal with this plus 4. That took you up to a positive 4. From there, they subtracted 9 from that, and that landed you on the negative 5. So the number line can be used to show you why the numbers are what they are, but it's not necessarily the best way to show the math. On a vertical number line, they started at 0, they added 4, and then they subtracted 9, and that took them right back to the negative 5 again. The same answer that they had the other way of doing it. Let's take and actually look at it using some real math. Now we're going to take and also use that thing that Mr. Reitz did a little bit ago, Mr. Reitz's rules, because Mr. Reitz's rules is quite honestly the best way to solve these. So we're starting off with the first problem, which is going to be a positive 5 minus a negative 11. That's what we call an ugly problem. You've got those two signs side by side, and remember, whenever you do have two signs side by side, you've got to have that parentheses between them. I'm going to make that ugly problem pretty by multiplying the signs. A negative times a negative is a positive, and that just gives me 5 plus 7, otherwise known as 12, which is the same thing that you guys have been doing with for a while. So we're going to clear that one out. Whoops, I missed part of it there. Let's get that piece too. We're going to clear that out, and we're going to get ready for the next question. And this one belongs to you guys. Pause the video and work this problem on your own. So how did that one go for you? Started off, got an ugly problem again. Let's make that ugly problem pretty by multiplying the signs. A negative times a negative, that's going to be a positive. So now I have 10 plus 19. That's old school math. Now you can do this other steps. You can do step 2, signs are the same, find the sum. All right, that's 29. So in front of a larger number, you have positive 29. But when it gets to be 10 plus 19, quit stressing about it. You already know what the answer is going to be. Answer 29, check your answer, and it's going to work. Now example number 2 on our textbook gets a little bit more exciting. So we're going to take and clear off everything that, whoops, that's not what I want to do here. I want to get this. We're going to clear off everything that we did there, and then we're going to go back and we're going to put in negative 24 minus a negative 17. That looks pretty tough. Negative 24 minus a negative 17. Ugly problem. First step, you got two signs side by side, and anytime you have two signs side by side, you do step 1. And step 1 says multiply the signs. A negative times a negative is a positive. So now I have a negative 24 plus 17. This time we have to do step 2. And on step 2, you've got, if signs are different, find the difference. So we have different signs, a negative and a positive involved in line 2. That means we're going to find the difference, and the difference between 24 and 17, that is going to be, I believe it's 8. Finally, step 3, sign in front of your larger number. 24 is your larger number. It is going to be a negative, so your answer is going to be a negative 8. Nothing at all to solving these problems. Now the textbook did all kinds of fancy artsy things here, I do believe, where they use the number lines and whatnot. No, they use other scary stuff. So no, they actually did what I did. They took, so that would be a 17, you positive 17, put them there. They made the ugly problem pretty, and then they found the difference being a positive 8. I'm actually impressed. The textbook, oops, did I do something wrong? Oh, it should actually be 7, shouldn't it? Yep, Mr. Reitz got that one wrong again. Now I'm really confused. Oh, negative 7. I forgot to put my sign up on a larger number because I've been talking and running my mouth here. Negative 7 should have been your answer on that one. Still, I'm impressed. They did my step one. They multiplied the signs, making that ugly problem pretty, because when you do that, everything else gets a lot easier. You guys go ahead and pause the video, work on extra example number 2 right now. How did it go for you? Well, we've got a negative 31 minus a negative 15. Can you say ugly problem? It's an ugly problem, folks. So we're going to start off by making that ugly problem pretty, multiplying our signs. A negative times a negative, that's going to be a positive. So now I have a negative 31 plus 15. That takes me straight to step 2. Signs are different, negative and a positive. Find the difference. The difference between 31 and 15 is going to be 16. Finally, the sign in front of a larger number is negative. Negative 16 should be our answer. Let's see if I did better on this one. I'm going to take a negative 16. I'm going to hit check. Uh-oh. What did I? Oh, I miswrote it. It should be 45 instead of 15. Well, for the one I did, I'd be right, but let's go ahead and fix it. We're going to take and do a 45 here and a 45 here. That means that this little dandy's can end up going away because it will no longer be the bigger number. And it also means that all of this is going to go away as well. And let's try this again. So now we have signs are different. Find the difference. And what's funny is it's still going to be a 16 there, I do believe. 31, 45, yep, that's still, nope. It's not going to be 16 either. That's going to be 41. It's going to be a 14. And then the top 45 is larger, so our answer can be a positive 14. All right, did I get it right? Let's find out. Ah, we did. Perfect. Now for the next problem, the textbook got all kind of stupid on us. I mean, they just simply did. They made things way harder than they have to be. Let's take a look at what they did, and then we're going to discuss what Mr. Rietz's rules say to do. The original problem was x minus y, where x is negative 23 and y is 19. So they took and put in from there, all right, x is negative 23. Where you had an x, they made it negative 23. And then they subtracted what from it? Y is 19. They made it 19. Perfect. No issue with that. And then they had to go off and get stupid on us and make it an ugly problem. There is no reason to do what they're doing right here. The goal was to make the ugly problem pretty, right? So we're going to pretend that line doesn't exist at all, and we're just going to skip right over it. On top, signs are the same. Find the sum. The sum is going to be 42. Sign in front of a larger number goes in front of your answer, giving you negative 42 that you can type in the box if you want to hear happy sounds, and that's going to give you the right answer. Nothing hard about this. Don't be like the textbook. Don't make it harder than it has to be. Keep it simple. All right? But still got to show exactly what I'm showing. So now you guys take a minute and do extra example number 3 and work this one on your own. We can get it to actually come up. There it is. Go ahead and solve that problem for us. Alright, looking at this problem, we're going to substitute in the things that we know. And what do we know? We know that m is negative 23. Minus, that minus sign came from right there. And what are we subtracting from it? We are subtracting a positive 44. Now we're not going to go stupid like the textbook did. We already have a pretty problem. We can completely skip step 1. There's no signs to multiply that are side by side. Instead, we're going to go to step 2, which says in this case signs are the same, so we're going to find the sum. The sum of 23 and 44, that is going to be 67, and then 44 is your larger number, goes to step 3. The sign in front of the larger number goes in front of your answer. Negative 67 is going to be your answer. If we jump back to the textbook page, put in our negative 67. Please let Mr. Rietz have got it right this time, and hey, I actually did one right. Now the textbook has a video for us to watch on how to find the distance between integers. Let's see what they have to say.
One way to find the distance between two integers is by using a number line. Start by plotting the two integers on the number line. Next, count the number of units between the integers. Counting the number of units shows that the distance between -4 and 5 is 9 units. You can also find the distance between two integers by using an expression. The distance between two integers is equal to the absolute value of their difference. Begin by writing an expression that shows the difference of the two integers between absolute value bars. Now simplify the expression. First, subtract the integers. Then find the absolute value. This method also shows that the distance between -4 and 5 is 9 units.
I think they did a pretty good job of explaining that. They showed it to you on a number line, and they showed it to you as an expression. We will, of course, be using the expression approach on
One
our
way to
homework
find the
tonight,
distance
not the number line. Example number 4, find the distance between two integers, and the distance they want is going to be -9 and 8. Let's see here. We're going to skip over the number line because we just don't care about it. And what they have set up is, ooh, they just made it really ugly, didn't they? So they took, and we're just going to skip over that, and we'll go back to the original problem, the distance between -9 and 8. Just like they said, we're going to write it as a subtraction problem. So all we have to do to find that distance between them is -9 minus 8. Okay? Now, from there, they're going to take and do the they also wanted to list that as an absolute value because they're not asking for positive or negative values. They just want to know how far those two values are to get from each other. So from here, we can take and say signs are the same, find the sum. The sum of 9 and 8 is, of course, going to be 17 with a sign from the larger number going in front of the answer. But they want the absolute value of that. And the absolute value of any number, that is going to be the positive version of that number. So jumping back over to our textbook, we can take and look at their method 2. And what did they get? They got the same positive 17 that I did. Why I didn't like what they did? They made their pretty problem ugly. They set it up just like I did here, and then for some stupid reason, they went off and made the pretty problem ugly. Got the same absolute value, -17 I did, for a positive answer of 17, which you can type in the box if you want to. Now you go ahead, pause the video, and I want you to do this one on your own. Remember, you're looking for the absolute value, and it's going to be a subtraction problem. Go ahead and work on this one. How did it work out for you? So we're looking at here the distance between a -12 and a +7. So we're going to take from here and set up our problem as an absolute value problem where I've got the absolute value of -12 minus a +7. Signs are the same, so we're going to find the sum. The sum of 12 and 7 is going to be 19 with a sign up on a larger number going in front of the answer, but that still needs to be an absolute value. The absolute value of -19, the absolute value of any number, is going to be the positive version of that number. So from there, +19, easy math. Anybody can do this stuff. The last example they give us, example number 5, involves a word problem. They say the highest point in California is going to be 14,494 feet. The lowest point is in Death Valley, and that's going to be -282 feet. From there, we're going to take and find the difference between those, but it's going to be the absolute value of it because they only want to know the distance between them. No positives, no negatives. So let's take and we got to do the absolute value of 14,494 feet minus, what row? We got a big issue going on, fixing to jump up, minus a -282. And here's where the big issue is going to be. Now I've got an ugly problem going on. I just did minus a negative. We're going to make that ugly problem pretty. 14,494. A negative times a positive become a positive. 292. Close it with our absolute value bars. Now we're just going to add those two together. That's going to end up giving me a, let's see, a 6, and then we're going to have an 18, carry the 1, a 6, a 7, and then that's going to leave me with a 4 and a 1. That is still inside the absolute value. The answer in the absolute value problem is always positive, so your positive answers can be 14,786. That's how I would do it. Let's take a look and see what they did. They started out the same way. Are they going to make my ugly problem pretty? Yes, they did. They made the ugly problem pretty by multiplying the signs. From there, they added them up, and from there, they did the absolute value, which gave the same 14,776, and we get a happy sound. Easy math. Anybody can do this stuff. All right, this last problem is going to be yours to work on. Please do that while I growl at a couple of students in my class that are playing handsies with each other instead of doing what they're supposed to be doing. All right, the problem is to find this. Earth's temperature can vary from a minimum of negative 126 to a maximum of 136, and they want to find out once again what's the distance between these two numbers. So we're going to start off with a minimum that is going to be a negative, come on, pick up the pen, negative 126 minus the maximum, which is, I believe it said 136. Am I right? Yep, 136, and we're going to include absolute value for those. No ugly problem. Don't have to multiply the signs. We're going to completely skip over step 1 and dive straight into step 2, which is signs are the same, find the sum. So we're going to add those up. That's going to end up giving me, let's see, a 12, a 6, and a 2, 262. Sign up for a larger number. That's right there. It's going to be negative 262, but the absolute value of that number is going to be a positive 262, which is what we should be able to get a happy sound with. Let's type it in here, positive 262, check the answer, and that's it. That's all we have for the lesson today. Now you guys get started working on your homework, making sure to give me the same good quality supporting work that I just gave you.